Question 18. A quadratic function is given by the equation f of x equals 3x squared plus 4x plus c. Determine the possible values of c if f of x has two distinct real zeros. Now, the way to get started on this question is to recognise that we need to look at the discriminant and we need to allow it to be greater than 0. Now, a little bit of background here. What are we talking about with two distinct real zeros? Well, zeros are x-intercepts. So a quadratic function is a parabola. Now remember that there's 6 real possibilities for how a parabola sits on a Cartesian plane. It can either be upright and cross the x-axis in two places, or it could do the same thing but be upside down. Or it could just cross the x-axis once, just touching it like y equals x squared does, and it can do the same thing while being upside down, also moved left and right obviously. The other option is that it's either what I would call up there in the sky or down below ground, and it never actually crosses the x-axis at all. Now, how do you find x-intercepts? You let y equal 0, don't you? Or let f of x equal 0. And if I let this whole thing equal 0, I can't really solve it like this because I can't factorise because I don't know the value of c. But I could throw it into the quadratic formula, and when I go to do that, the entire formula looks like this. Minus b plus or minus the square root of b squared minus 4ac over 2a. Now, it's this part here, the b squared minus 4ac part, what we call the discriminant, that decides how many zeros or intercepts there's going to be. Because if this is exactly 0, the square root of 0 is 0, and whether you add or subtract 0, you're just going to get one answer. So that means one intercept. If b squared minus 4ac is negative, you can't take the square root of a negative number at all, so there'll be no solutions, and it'll be one of those ones that's up in the sky or below ground. But if b squared minus 4ac is greater than 0, then there'll be two answers or two solutions, two intercepts. So that's what we're thinking of here. We need to let b squared minus 4ac be greater than 0. Now, some people find it handy to jot down that a is 3, b is 4, and in this case c is just c. So on the next step we just want to sub in b squared will be 4 squared minus 4 times a times c. Has to be greater than 0. Now tidying up, we've got 16 minus 12c is greater than 0. So adding 12c to both sides, I've got 16 is greater than 12c, and here I've just divided both sides by 12 and simplified. And so now I can see that c has to be less than 4/3, and that's my solution.